I'm really excited to be talking to everybody today about how we're actually starting to design data infrastructure and maybe what does and doesn't work as we move into this age of generative AI. There's just so many new tools that are now coming about, different ways that we're using data. And that's really important in terms of how we actually design the fundamentals of our infrastructure, work with what we already have, et cetera, et cetera. So a little bit about me, staff DevRel now at Databricks. I've been here for a few months now, so not terribly long, but Matt gave me a beautiful introduction, so I'm not going to add too much more to that, but I'm really excited to be here, and I'm very passionate about open source. Open source has built my entire career, so I'm really excited to have a job where I can talk about it. So really, I want to get into this point of the way that we're working with data these days is quite fundamentally changing, but also the percentages and the makeup of the data that we work with. So this isn't to say that we no longer work with structured data or we work with less structured data. We actually work with more data now, tabular data even, compared to before. Like that big data boom is not going anywhere. But now sharing that piece of the pie is also multimodal data in a really significant way beyond just, I think, previously a lot of the computer vision work that we did. So now, alongside tabular data, we're now working with a lot more semi-structured data and a lot more unstructured data, a lot more video, et cetera. And the expectations around the way that consumer-facing applications even use this data is quite different. So we look at different applications like maybe, short form content like Instagram or images or video, and it's all kind of meant to be processed in real time, which is really quite different from how us as data engineers are used to working with data and are used to preparing data and even the expectations around that versus traditional like NoSQL paradigms, right? Like we actually have to store context and work with context in different ways. And we're also working with, all this multimodal data alongside our structured data as well. So this is kind of what this whole slide is meant to really say, that we're expected to actually increase our processing and usage of multimodal data in general. At least that's what's projected in the future, and especially when it comes to the generative AI world. So this kind of begs the question then, do we actually evolve our existing paradigms in terms of data infrastructure and tooling to adopt and be able to use these new use cases or, these new features? Or do we just change out tools within the stack and then kind of pray that it all works, right? And this is a really important question because when we think about data infrastructure in general, it's quite slow to change. That's the whole point of infrastructure, is that it's not supposed to be very quick and it's supposed to be very stable. And so I want to beg this question because it's actually not a new problem that we faced in the past. This is something that is a natural evolution of data engineering where all of the tools eventually shift over in different generations. And I think a really great example of this is Apache Iceberg and Delta Lake, taking over from Hive and Hadoop, right? And the way that we actually work with these different open table formats is still very much quote unquote new in terms of the data engineering world. If I look at the companies that are fully migrated to say something like Iceberg or Delta Lake, it might be quite limited because they might also be side by side running Hadoop as well. So even though Iceberg might be pretty much like a better open table format or much more user friendly, it's not necessarily like, overnight people switch, right? Like you bring all of this old stuff with you into the new, and then you use the new where you can, and then you do phase migration. That's just like basic DevOps, and that's just the reality of infrastructure. This is also really important because the fundamentals of these tools are actually quite shared. So if we look at something like Parquet, Parquet is the basis of both Iceberg and Delta Lake, right? And Arrow as well. So any fundamental changes that we make to Parquet, and Parquet is now adjusting itself and creating new features that help, sort of with generative AI data processing and semi-structured data. We'll talk about that a little bit later with Variant. Generally speaking, this also happens in parallel. So generally speaking, like these tools go through their evolutions, but they don't always completely go away. And it's kind of naive to think that, okay, generative AI is here, new tools are here, let's just all switch everything over. That's just not how it works. So what are some examples of the ways that open table formats are actually adapting to, new multimodal use cases? So I think a really great example, and these are, features that are shared between both Delta Lake and Iceberg, are, the use of binary columns, so storing raw data in the column itself. So this can be, raw bytes, and then also, storing that in there. This can be a little bit slow, and you want to limit the amount of times that you do this, because then anytime a query engine has to scan that table, it's scanning that entire blob too. So you actually don't want to do that if you really like care about latency, for instance. We'll talk about that later. You can also say have an external object store where then you reference that store or you reference the location in that path within the table itself, right? And so we call this sort of a column of URLs where you just have like a list of files that you're referencing. And then each time you want to look it up as a query engine, you actually like do that jump, right? This also has some downsides as well, though, because then you're not necessarily keeping as close of the eye on like the files in the object store as maybe you would want to. And there's a lot of risk for orphan files, things like that there as well. So maybe something in between is happening, but also between Delta Lake and Iceberg, there's also the possibility to evolve different APIs to be able to handle this data more. But to be honest, something like Iceberg is not really meant to like manage multimodal data, right? That's just not what it was designed for. And we have to have realistic expectations for what these table formats are meant to do if they're designed to do a very specific thing. Above the format, we also have different volumes that can be managed themselves by the catalogs. So Unity Catalog volumes can do this as well. But generally speaking, there's a lot of different levels where this can fit in. So if we talk a little bit more about the different ways that Iceberg and Parquet and Delta Lake are actually able to handle more, unstructured data, or at least semi-structured data, a new open standard called variant type is actually implemented now between all three of the projects, creating this uniform experience where you can store compact binary data within the actual, table itself. And this is meant to be used for, say, JSON data or CSV data or XML data. So you have a little bit more flexibility when it comes to semi-structured data storage within, or at least referencing within the actual open table format itself, right? And this is nice because if you have that interoperability at the Parquet level, and then also at the Delta Lake and the Iceberg level, you're then getting consistent behavior across all three of those open table formats. And then, that's really nice because then the way that you're able to manage them can be quite similar as well. And you have what's actually an open standard, right? And then if you have like a lot of nested columns, so you have a JSON file with a lot of nested columns, you can then use shredding to just take out those columns and then create new columns from them, or at least take out that data. And this is really nice because you sometimes want to be able to make it a little bit more performant. So what about multimodal native workloads? So we talked a little bit about unstructured data, but not really a lot compared to semi-structured data and just managing blobs. There are a lot of native multimodal formats that have kind of risen. I think LansDB is probably the one that's gained the most traction, at least from what I've seen. And this is really great because multimodal data, if compared to traditional structured data, is shaped really differently, right? It's very wide compared to traditional tabular data, and it's also GPU bound. The metadata fields that you also have, oftentimes, let's say, videos and images and vectors or even features, tend to be quite different. And so that's a very specific type of format. And so if you're building an open standard just around maybe multimodal data, will it be the best case scenario for, structured data to fit into? And then also, just like what I showed before, are we going to be able to constantly switch new tools? In my opinion, the realistic thing is that we'll have, our old data stores and proprietary formats alongside the open table formats like we currently do. And then we'll also have a multimodal format. So that's going to be much more complicated to work with. And that's sort of the reality of infrastructure, is that it gets messier with each generation. And it's sort of our job as data engineers to manage that messiness and then still, extrapolate value from those different pipelines that we see. And so how do we actually do that? And we'll get into that in a little bit, right? If you're working specifically with blob data using open table formats, there are a few different ways that you can create a little bit more of a performance system, like, selectively storing inline versus doing a reference out of line, like I mentioned before, instead of just doing one or the other. But generally speaking, I think from a data engineering perspective, keeping this zero copy ETL of multimodal data, or at least blob data, is probably going to be a little bit more what we see later when it comes to optimizations, because this is really expensive to keep multiple copies of this around, especially with all this like on-the-fly video editing and things like that. So it's really hard to manage these different versions. And it's a little bit messier compared to, say, a traditional open table format, which has a lot of rich metadata and is, built around snapshots and versions and commit files, things like that. So we have to kind of figure that out a little bit more. So I think it's really important to note that there's going to be a lot of fundamental differences. But regardless, we're still going to have these different table formats or at least like multimodal formats as well, because they're meant to leverage different tools. And when we think about the specialized tooling versus, general tooling, we also have to think about the hardware considerations for that as well. So tools like Daft and LansDB are very much GPU bound. And depending on how much a company invests in GPUs, they may want to leverage that much more in their workloads in the way that they're designing those at a low level versus, say, just CPU. I have seen some NPUs around, but I haven't seen like just a ton. To be honest, I think there's still some generations of NPUs before they, really become super widely available, if that does become the case. But it would be really awesome to see just at least one sort of processing unit that feels like it has a little bit more flexibility. Okay, so do we specialize or what is the right balance between everything, right? This is really hard because we've seen generations of data engineering tools that have both been very general, but have both been hyper specialized as well. And there's varying levels of success, right? If we look at a lot of the NoSQL tools that have been out, arguably they worked really well at the beginning for a lot of operational workloads or a lot of like normal application workloads. And then now for some reason they feel like maybe it's a little bit too specialized of a tool for a typical data engineering stack. And so this is really hard to predict, right? And in terms of infrastructure, we're always trying to make something that feels robust and that lasts a long time. And so we have just no idea what the right balance is. And arguably, there's probably no right balance for any given company. It's just really subjective in terms of what your goals are at that particular point, what the reality of your data is, et cetera. And so as part of this, I want to bring up this idea of a composable system, right? So in a traditional lakehouse, or at least a data lake format, we're thinking of something that's pretty centralized. We're dumping all the data into one place, maybe the multimodal data alongside the semi-structured data, alongside the tabular data. But in terms of how we actually leverage views and zero copy and things like that, it becomes quite messy. And I think from a governance perspective, this is quite hard to manage as well. You get like a swamp very easily. And so when we think about a composable system, we think about creating tools that can reuse assets from each other, not just from a data perspective, but also from a compute perspective, also from a governance perspective as well. This is really important for us to consider, right? Because if we think about the AI stack and the data stack, this is something that is really hard for us to think about, right? We have a very Python-centric AI stack that seems very GPU bound currently, almost hyper specialized for all these new tools and systems. And then we have the traditional data engineering stack that has been around for a while, continues to evolve, but now feels like it's trying to be retrofitted in a lot of ways. But at the same time, they need to leverage the same policies. They need to leverage the same tools because data is data is data is data. I don't really know how else to put it, right? At the same time that you have an agent being built, you don't want to have a completely different pipeline or stack that just caters to that one specific use case. That just seems really redundant to me, especially if you have no visibility into that system. And so this is really important, especially just in terms of governance, right? So this is kind of where we're seeing the shift right now towards catalog first architecture, where if we look at the previous slide, a lot of the one layer that I feel is shared across both different stacks right now is that catalog and is that observability layer. And observability can be powered by metadata just through logs and things like that, and through different instrumentation and tooling, et cetera. And so if we look at the catalog, it seems like kind of the best bet to converge all of these same places, especially in terms of governance, right? If you have AI assets, you kind of want them to be governed in the same way as your normal assets. There's not really much of a delineation there in terms of actual behavior. And so if we move towards a catalog first paradigm, we can sort of move towards that a little bit more. And what I mean by that is that a lot of the commits right now, in terms of, let's say I make a commit or a change to a particular file, that happens at the format level, right? Iceberg is a really great example of this, where Iceberg manages all these snapshots, manages all these commits, but it also leverages the Iceberg Rust catalog and that protocol to be able to offload a lot of that commit coordination to server-side services, right? Some sort of external implementation. And that then service coordinates all of these commits. This is something that wasn't really present in Delta up until recently with tools that we'll be talking about in a little bit, but Delta's not really the only one in this boat, right? There's other new formats that are coming out like LansDB that also are now making themselves more manageable by catalog. And so before, Delta commits were just kind of managed by Delta log, But now Delta can actually be managed within Catalog as well. And we'll see, like, we'll get into the details of that later. And if we then continue to do that and replicate that pattern across all of these other different table formats or multimodal formats, then that catalog becomes your source of truth for all of your query engines and all of your external tools, which is really awesome because then you're not dealing with this messiness that we'll see probably coming up a little bit later. So if we enable this, we can also have multi-table transactions, more unified policy delegation, things like less fragmentation across your entire system, et cetera. And then your query engines can then interface with the catalog and do all that commit coordination there. So the way that we're proposing to do this and the way that we have done this is through a tool called Delta Kernel. Delta Kernel is a community project that came out that actually implements an embedded interface. So it's written in Rust, designed to help any engine build and kind of spin up a Delta connector without necessarily having to understand the Delta protocol, right? And this is really cool because if you're abstracting out and you're offloading all of that, understanding of the protocol and the way that, the actual query engine interfaces with either the catalog or the table format, you can then manage different versions of engines and not really have to worry about it. And you get consistent behavior across all the engines that can actually embed a Delta kernel. And we'll get into this in a little bit because I know it's quite complicated, but this is really cool because Delta kernel actually, has dedicated APIs for working with, catalog managed commits through, like in this case, Unity Catalog. This is really cool because as long as then Unity Catalog can manage an interface with all these different formats, then the engines just have to work with UC, and it can do that really easily through Delta kernel. This allows then also for these engines who bring their own, special flavor to the table. In this case, we have Spark or Trino as good examples, or Flink, but we can also open this up to things like Polars or Daft, et cetera, that make it a little bit easier to then predictably work with this data. Okay. So this is really important because, the alternative to this is having all of these different engines across all these different stacks like Polars, Pulsar Array, Trino here are listed, managing and interfacing directly with the different table formats themselves, with the different, levels of, say, detail, right? The different behaviors that may be there. And that's a really hard pattern to replicate and actually govern over time versus embedding just a kernel within each of them that can then understand inherently the same behavior. And then when you're updating the Delta protocol, kernel, it is also up to date with it as well. It inherently understands a lot of these. So that provides a lot of compatibility in terms of APIs. So Delta kernel is picking up a lot of steam in the ecosystem right now, and there's a lot of different supported formats and engines that support kernel because it is like Rust native, and it is being implemented in Java. And so that covers a lot of the tooling and makes it pretty memory safe compared to, say, most of the tooling that we'll see out there currently. So if you're interested in kernel, it's, again, a community project. You can scan that QR code. It'll take you right to the repo. And this is really important for kind of shifting that architecture, again, towards a kernel like catalog-based format so that you're not then trying to pick and choose which tool is your favorite and then still being stuck with your old tools anyways, right? This is really important.